back, boys and girls, to another episode with Boolean Noob. As your host, I'm going to show you how to add or subtract hexadecimals with 8 bits. You ready to do this? I'm not, but let's do it. So, this is just an addition from a previous lab. You can look up Ripple carry 4 on YouTube. You'll find it there. So, no need to go over this because this is all the same basically it's all the same code. All you do is just copy paste it, or you can import it, include it, but because we're using the 2016 version, it won't work. So you just copy paste it. Here's the new guy, adder 8. Let's see what this adder 8 does. Give me a second first. I don't like this thing, so there you go. Okay. So what does this adder 8 do? Well, instead of adding 4 bits, we're going to add 8. That's all it really is. Okay, so we have this input Cn, which is our carry in. This A array, this B array, and this S array. A and B are inputs, S is output, which is our sum, S is our sum. A and B are two numbers. And C out, our output, which is our carry out. So all it's going to do is going to call this Ripple carry 4 module. And it's going to pass in these values. Cn, 4 numbers for A, 4 numbers for B, assigning 4, or not numbers, integers, sorry, 4 to integers for S, and C out 3. And same thing for this other call. It's going to input, instead of Cin, carry in, it's going to do the carry out, whatever that wire is going to be. The last 4 digits, that's 4 digits, and that's 4 digits of A, B, and S respectively, and it's gonna also determine what this carry out is. And I don't know why I have this extra part. Let's delete it. Okay, so that's that. That's what this adder 8 thing is. And now, unfortunately, I can't zoom out of here. Whoops, there you go. Okay, so that's that. Let's look at the schematic for this. Let's just make sure. Oh, it's on Subtractor. So let's make this as a top one, so we can see what the schematic looks like for the adder. Ready? Save, yes, and okay, and oh, okay. Let it run real quick. Letting it run, so you believe that actually works. Can believe me. Alright, here we go. So you can see it works perfectly. These are 2 numbers. This is our carry in. Carry in should be technically 0, right? But whatever. So our first number goes to the Ripple carry 4 from last time. So if I expand this, it's going to look exactly the same thing as last time. So you can look it up. But anyways, it goes in there. And it spits out whatever, if there's a carry, and then in the numbers when it adds it. And that goes into the next again. Okay. And the 2 numbers are added as well. Spits out carry out if there's any carry out. Okay. Not much to see here. More interesting is the subtractor. This is the subtractor. What does subtractor do? So subtractor, we have a couple variables here. We have a bn variable, 2 arrays, A and B, 3 arrays for difference. Now we're going to be doing subtraction, right? We need an answer variable called difference. Okay, and an output B out. This wire called E. Now what it's going to do is going to get each array value from E and pass it into this XOR function that's going to basically do an XOR operation on these numbers, right? E1 and B1, B1, B0. Oh, interesting. This should be B0. I don't know. I thought I tested it. And Bn. Adder 8. Here, what it does is call adder 8 and passes in this Bn, our bn value, which is our I forgot what it does right now. I'll remember. I'll explain it to you if I remember. Okay, yeah, now I'm wondering what bn is again. Alright, I just completely forgot right now. I'll remember. So, it passes an array, A, all 8 bits. This E wire, which is 8 an array of 8 values, our difference variable, and our B out as well. I'll remember what that is in a sec. Okay. So that's our subtractor. So let's look at the subtractor. Let's say that should automatically make it as a top. And it didn't, so do it manually. Let's reload this. Waiting. Alright, so here we go. Bunch of stuff going on here. Let's pop this out. There we go, that's better. So what's going on here? We have a couple inputs, or bin, right? Some XOR functions, and all it does is takes in the two numbers and it produces an XOR between them. Okay, so this A is actually going to just adder first. Okay, and whatever the output or the output of the XOR functions, passing in a bin, is the input for this B function. Okay, so it's going to perform these XOR functions and then perform the adder, call the adder A module, and perform that function, that operation. And it's going to spit out the difference between them. And if either of them had, oh, there we go, B is borrow. So borrow in or borrow out. It's going to spit out borrow out if it needs to. Okay, so that was the schematic. Let's look at the test bench. Test bench was given to us by that professor. Be straightforward. We have a couple of new variables here, add 0 sub 1, which is just going to be corresponding to the name of our of whatever operation we're doing, adding or subtracting. We have A and B arrays, sum difference arrays, carry borrow arrays. For adding, we're going to call the adder. For subtracting, we're going to call the subtractor, but again, remember, technically also calls the adder. It just flips the operations. We have this for loop here to do it 10 times. Okay, and all it's going to do is it's going to randomize a couple numbers. And it calls this test case, which is down here, this task. And all it does is going to display, if it's an adder, then it's going to display this stuff. If it's a subtractor, then it's going to display this stuff. And that's all there is really for this test bench. A couple syntax stuff in there. Anyways, let's run this test bench. Run the simulation. Say yes. Close the other one. We're almost done here, guys. No worries. Couple more seconds. Good to go. Here we go. And I think I'll invert colors again for this. There we go. Let's pop this out. Zoom out so we can. There we go. Cool. So, what have we got here? Well, looks like we have a couple numbers here coming on. So 9A plus 92 is 2C. Let's see if that's true. I don't think you'll be able to see my screen for this. So I'm gonna whip out, or actually, let's see. Programmer calculator. Let's see. Might work here. Okay, looks promising. 9A plus 92. Let's hopefully you can see this. Okay, hopefully. Plus 92 in hex. Cool. Should be 12C in hex. So let's look at this. 2C. Why? Well, it looks like there's a carry flag, right? This my carry variable carried the 1, so that's correct. Okay, and I'm pretty confident that all the other addition is fine. Let's look at I don't know, this one randomly. I tried it. First subtractor. How do I clear this? A9. Again, hopefully you can see this. If not, I'm sorry. All I'm doing here is calling using a calculator, programmer calculator to see what the actual number should be compared to what I have here. Except I've never used it. So, here. There we go. A9 minus 09 equals A0 in hex. So here we got var 0. The answer here is B2 for some reason. I don't know. Don't know. We could use a subtractor again, I guess. I didn't see anything wrong with it. I don't know. The error's right then. Something's wrong with the subtractor. I can't find it though. Can't find the error. Something's wrong in there though. Anyways, that was this lab. Hope you enjoyed. See you next time. Make sure to like and subscribe. See ya.